Nintendo Switch. Let's take a look at what's going on. I think we have some port damage. I don't see anything bent, so it might just be a port issue. See if I can get that clearly in focus for you guys. Anyway, we will disassemble, remove the port, replace the port. Well, remove the port, then we'll do some further testing, replace the port, and go from there. Okay, we are prepped. The board is pulled, and we are going to prep the port for removal. While I set up my equipment, let's throw up the temps we'll be using in today's video. Probably will not use the Pico pencil unless there is trace damage under the port. If we do, that'll be the temperature we use it at. And let's make sure everybody's up on their correct temps. All right, it's all good. Okay, let's get you focused and me focused. We will do what we always do. We will flood with low melt and go from there. Okay, looks like a good pull. This was clearly broken. The whole shield is broken, so. But we'll come over here and look and see if we have any bridges, and if we don't have any bridges, we'll do some testing. First, I want to flip the board because the rest of the work we'll be doing on the other side. Alright. Doesn't appear to be any bridging pins that would affect our measurements. Alright, let's make sure we are connected. Not that it matters that much. We'll be doing continuity. That's the reason why I say it doesn't matter that much. What I am listening for is the beep. Not really watching the readings. Okay, that's the P13 USB capacitor. Now we're looking at signal side of these capacitors. Unless it has two lines going to the chip, we don't want the line going to the chip to be shorted to ground. Now, if it has two lines, one of those will typically be ground, but like this one has two lines, so that line is ground. This line is not. Okay, everything looks good there. We want continuity through this filter. Okay. Alright, no shorts there. We want continuity through that filter. We want no shorts on any of these test points. None of these should be going to ground. And they're not. Alright. Let's move this rather disgusting pad at the moment. We do not want this filter shorted to ground, but we do want it to have continuity through. Same deal with this. We're looking for one side. If it has two signals to the chip or two lines to the chip, we want one side to be ground, one side not to be. In this case, this is another one with two lines. That's ground. This is not. Alright, everything looks good there. Let's measure around our P13 USB. Or could be P13 USB or it could be PI3 USB. Seems to be some debate on which one that is. First thing we want to measure is these filters. We want them to have continuity through, but not side to side. Can be a little challenging getting readings on these because there's usually some residue left over from the manufacturing process. It makes getting a good connection challenging sometimes. And this is the same on like an Xbox or a PS4 too. You gotta make sure you're making good connection before you draw conclusions. Alright, we're going to check the signal side of this capacitor that goes to the Pi3 USB or P13, whichever you want to call it. This is the signal side, that's ground, and everything seems to be okay. So hopefully all we have is an issue with the port. We will clean up and put a new port on. Get you centered and everything. And go from there. Okay, I think we're about ready to perform a test and see what our type of behavior we get. The switch does not seem like it was all that well cared for. So, could be other problems, we don't know. But we're on, we're the right voltage, so let's see what happens. Is it just hanging? Interesting. I don't want to say it's being abnormal, but I'm used to it going back to zero at some point. I'm not going to say there's anything going on abnormal. It's not a typical reading, but we will throw it into the housing and see what happens and go from there. Okay, we're together enough to perform a test with a known good battery. I did build one of those test squids like Phil made, the coder. And I might put it to the test at some point here. But I have a charged known good battery for most cases, so I'll use that for this. But if we get a different behavior than what I'm expecting, I may use it just to see what we're getting from that. Alright. Let's plug it up, see what happens. Okay, powering up. And we're into the system. Pulling 0.98. Let's try the other side. And pulling 1 amp on the other side. Good. We're charging both sides. Everything appears to be good. So we will power it back down, reassemble entirely, let it charge its own battery, and we'll come back and do some more tests, including the dock tests. Okay, we are powered up. Although you can even see that, but we are charging the console and the Joy-Cons. Close that and do a quick check on our internet. Ugh, this thing is seen better days. But I am responsible for the port. Somebody else can deal with the other problems. Alright, we're seeing all of our networks with the magnificent drift on the Joy-Con. I'm going to let it charge a little bit more and then we'll do a setup for a dock test. Okay, we've charged up a little bit more, and as you can see, we are getting dock sync. That's really all I have for you in this video. If you have any questions about the equipment I used in this video, take a look in the description below. They're all linked down there. If you like this type of if you like this video, hit the like button. And if you like this type of content, hit the subscribe button, maybe hit the notification bell, and you'll know whenever I post a video. Right now I post about 2 videos a week. So I appreciate you watching this one, and we'll see you next time.